So we're going to go for our last day, tinker with setting up a site-to-site VPN. We're going to use pfSense, then when we're done with that, we'll talk about what the last lab will entail and creating the open VPN config and all that good stuff. That should be posted and the VMs should be out there and whatnot. So we did have an interesting experience last night, though, where someone actually encountered. We talked about a DLP system, a data loss prevention. So one of the things at DSU, if you actually try to email things that appear to be credit card numbers or social security numbers, the message will get flagged because there's regular expressions that scan all of your outbound emails, and you'll actually get a bounce back message. So if I try to send a message out and then do the goats SSN is 437 dash, what is it, a 2-digit, then a 4. So the only way I can actually come up with the digits of a social security number is when I read mine off in my head to know the placeholders. I'm like, well, I'm not going to do that. So we'll send that away, and whoops, here we go. I get an instant reply of social security number detected. Can't do that. That's frowned upon. So although it is not the most advanced system in the world, because there's probably really creative ways that you can get around it, like putting a letter between the numbers or something like that, and I'm sure the regex will fail. But at that point, you're getting around it, and you've probably been told that this is dumb, and don't email this out to someone by said message. But anyway, that is the example of data loss prevention. Just so happened that I was reminded that we have that turned on yesterday. So anyway, heads up if you do that, or if you email your credit card numbers out to someone. So, did we get a hi back? So Dave is our security officer that's in charge of handling all of those fun things. So he probably chuckles when he gets those messages. So there's one time I sent out a message that I was just checking to see if it worked, and I made it look real. And they're like, oh my gosh, you tried to send out your social security number. And I'm like, yeah, my social security number's not 8675309, something. And then they're like, oh, no, it's probably not, is it? So the IT department thought they had me, and I'm like, no, I was just being dumb on purpose. So what we're going to do today is talk about IPsec VPNs. How many of you have done IPsec VPNs before? Yeah, and routing and switching, you basically match up the fields, right? So we'll go through and set that up inside of pfSense just so we get a rough idea of checking logs and stuff like that in there. And then visit about doing the lab that's out there. So the specific thing is I'm not going to show you how to do the OpenVPN lab because that is our final little research project to go discover and learn how to do that. The other case in point being someday your boss is going to come to you and say, hey, you need to do this. You're like, well, I don't know how. Your boss is like, yep, me neither. Go do it anyway. And that's how projects like that start. So with IPsec, it's there's a lot of ways that we can do VPN stuff. So in the case of doing OpenVPN, you actually have to install some sort of client software on your computer in order to route the traffic. With IPsec, we can actually do this at the router level, and it's actually a protocol that just lives within the OSI model. So there's a couple different ways that that we can do it. We can do it at the transport layer where it's really just extending like an IP network across the internet without having to worry about routes. Or we can do it in tunnel mode where we take the entire packet and encrypt it. So the reasons why we actually have to tinker with IP pieces of this is because we're taking IP or network packets that are probably addressed to something like 192.168, whatever, and we're shipping that packet across the internet, and it has to arrive at its destination and then poof back onto another local network to actually get to its location. So that's the neat thing that this does. So IPsec is used in some instances to actually just deliver traffic that doesn't need to be protected across the internet by just stretching networks out like that. If where I have seen students use this before is there's been some games that you can play on a LAN locally, but when you go out on the internet, you can't pick who you're playing against. So if you have people at different houses and you wanted to all play together, well, you couldn't unless you all came to the same house, and that's forbidden if you're gaming. So instead of like driving down the street and everyone just sitting in someone else's living room or whatever, we took the nerd approach, and everyone set up an IPsec VPN that actually just stretched their IP networks across, so that everyone appeared to be on the same network. The game would connect. And it was only encrypting the actual IP headers. It wasn't encrypting the data. So what does that mean in terms of your game?
Less latency.
Yeah, we reduce latency because there's less overhead on all the computing and stuff. So it's kind of a cool thing. And then IPsec is really, really modular. So we can plop different things in at different stages. So when it comes to actually setting this up, there's an authentication phase and a transport phase. So the authentication phase is dealing with proving that you're someone that we actually want to do the VPN with. So that phase, we usually, we also use the authentication phase for actually exchanging encryption data. The authentication phase doesn't actually transport information for you. It's just the first step in, kind of like when you go to a website and you get the green bar that's like, oh, I trust this website now. That's what authentication is doing, is establishing trust with a third party or some other outside entity, whereas transport's actually hauling the packets back and forth for you. So for the authentication phase, actually if we want to look over here, there's an in-class VPN set of machines. I should have told you that ahead of time, because we'll start to tinker around with these. So there's a Chicago and a Minneapolis machine inside of there. Well, this will be a real quick class if the console proxy server is dying. Oh no, it's there. Just took it a minute. There we go. So I'll log into these. Not that this is an important part of how VPNs work, because you start by logging into Windows. So the key part of this authentication phase is you and I identifying each other. So there's a lot of ways that we can use to actually do the real identification. We can use fully FQDNs, fully qualified domain names. We can use IP addresses. We can use tons and tons of stuff. What are pro cons for using IP addresses to actually identify an outside party you're trying to connect to? You don't have to worry about the DNS service working, right? Yeah. What's a downside to using IPs?
Trying to allow somebody like a home user to use it, their IP could possibly change.
They won't necessarily have a static IP address all the time. Yeah. So that's the kind of pro con. The same thing kind of comes up for DNS then is DNS, we have to make sure the DNS service is actually working and configured properly and all that good stuff. But the problem of having like a home user whose IP address is rotating all the time, that's not really going to get a whole lot better. But there are some solutions with DNS in that, has anyone seen like a no IP service before? Something that like Dyn offers, there's a bunch of places offer it, that when your IP address changes, there's a service running on your computer at home that automatically updates a DNS record for you, and life is good. So there's a couple of ways to get around that. Then when we have those identifiers, we choose what are we actually going to do to authenticate. So what's PSK? You'll see PSK a lot in stuff. Yeah, pre-shared key, which is equivalent to just a password, right? So assuming whatever we used for identifiers matched, the other thing we need to verify is either a pre-shared key, or if we say RSA, what are we talking about doing then?
The whole public key, private key.
Yeah, we have to have keys working. So we have to have public key, private key, which means we probably have to have a certificate authority that we trust issue a public and a private key out. Do we have to go buy it?
Not necessarily.
No, we don't have to.
Well, you could self-sign.
And
Let's Encrypt.
so Let's Encrypt's an interesting one.
Uh-oh.
So you can generate your own certificate authority that can issue out certificates. And if it's just for your stuff, sure, go ahead and install that certificate authority on all your devices, and that's fine, that's cool. If you actually look at DSU, if you log in on an Active Directory computer, you will notice we don't issue self-signed certificates for stuff at DSU that's internal, that would be Active Directory-y things. We have our own CA that through Active Directory and using group policy, we pushed the certificate out to all of our computers. Now, your computers aren't going to trust it. Your computers are going to give you a certificate warning. But that's a very enterprisey thing to do. If you think about all the things that DSU has certificates on, imagine what our certificate budget would be to just go buy, even if they're $9 a piece, to go buy certs for all of our stuff. It would be silly. So it's easier for us to spin up our own certificate authority and install it on everything, because these aren't public things. These are things that are internal, like accessing the share server, accessing the print server, stuff like that. So our CA issues out the certificates. Well, all of our devices that are DSU managed trust that CA, so all of our users are fine. So we could do the same thing here. We could issue out our own certificates that way, create a CA. And that's actually what you have to do for the Open VPN Lab. You'll create a certificate authority, a CA, to issue out a server certificate and a key, and a client certificate and a key, like so. Anyway, that's the RSA way of doing stuff. So why do people sell certificates then?
Easier that way.
So what is the perk? Yeah, so their CA went through the effort of talking to Mozilla to get their certificate trusted in Firefox, and talking to Microsoft, and talking to Apple, and talking to Chrome or Google or all these different places. They went through that effort and had, I don't know, some sort of under the table, like, yeah, we got this. Therefore, they ship it. What's that? Yes. Because they were like free, and they were opposed by all the things. As my understanding of Let's Encrypt, the way that works is it's essentially free certificates. However, they're not necessarily certificates that you can just dump on any sort of device, because they have some sort of a service you have to run on your...
They expire really quickly.
Okay.
You have like 2 or 3 months.
So they have a service you install that renews the certificate for you.
And every time you do that, they have to verify that, hey, you actually own this domain, etc.
Yeah.
So it's not just a free certificate to whoever wants it. There's so much shipping.
Oh, for sure. And that's the thing with all of whenever you get any sort of certificate, like I can't, well, I probably could go off to Namecheap and buy a certificate for dsu.edu. Because at some point you have to show some way that you own the domain, and that's I guess a good point for stuff. For what do certificate providers usually make you do? What are some options? Yeah, you get the green bar.
Regular, you could probably buy. Not very much.
Yeah, so when you get like the $9 certificates here, when you're actually doing an RSA cert, usually what they're going to do is look up the whois data for the domain and want to send an email to it. Or they'll say, take this string of text and put it in a file called this on the like dsu.edu website. And then they'll do a GET request and ask for it. So those are tough to spoof, right? I mean, it's still spoofable, but tough.
I don't remember the outcome of it, but I remember a month ago or so back, there was a snafu with Let's Encrypt where phishing sites started using it. So users go to it and they see the green lock or oh, okay, it's fine.
Yeah, I mean, that's a thing. So we've trained people enough that when they go to a website, you have to look for the green lock, right? So people that are doing phishing realize, like, well, if I'm trying to steal someone's credentials, I have to show the green lock. And it used to be a thing where they would actually use the favicon. You know what the favicons are? Like when you go to, I think DSU uses them. If I look in the, oh yeah, right there. You see a little DSU logo where my mouse cursor is? That's our favicon. And it's just, that's what they're called. They're favicons. So they would actually use the favicon for their spoof domain and make it a padlock. So users would be like, oh, there's a padlock there. So that's why you notice most browsers now usually only display the favicons in bookmark bars. They don't actually display it when you go to them. I can check Firefox too. I don't think they still display the favicon. Whoops, why am I going to Fire? I want to go. Oh, it displays it up here. Yeah. But not in the bar where the padlock goes. Yeah. So the favicons used to appear like right here, right next to where the padlock would go. So yeah, that's a thing for phishing sites with using free SSL certificates like Let's Encrypt because they own the domain. So they're really not breaking the rules necessarily.
Yeah.
I mean,
they also only issue a certain amount of certs. So if you're trying to have multiple sites, you can only do so many.
mm-hmm. In my, personally, for me, if I was going to set up an IPsec VPN within my organization and actually do RSA for authentication, I would just use my internal CA for it. Because when we're talking about, at least here we're talking about doing a point-to-point VPN between like two different routers, is a user ever going to encounter the certificate? No. This is just certificates that routers are going to be configured to use. So even if you did have users that were encountering it, having an internal CA certificate, assuming they're your users, you control their computers, that's not a big deal anyway. So that's my whole summary there. So I probably wouldn't go through the effort of doing Let's Encrypt with that. I would just issue my own certificates for it. Make a big key, make it last a long time. You'd be good. So the next two parts of this, the policy and proposal checking, those are basically compatibility things. There's some devices that just don't support certain features, so we match these up between the two. It's not like there's necessarily things that are more secure than others. It's just, here are the algorithms we support for exchanging data back and forth, and what all do you support. This is where things start to get important, though, is what encryption and hashing algorithms that you select, and we've talked all about those. And then this is the other one, is how often do the keys expire? So when you do something like on, any sort of network exchange back and forth, we want the keys to be rotated on a regular basis. Why do we actually want to do that? Yeah. So if we have an encryption key that we've negotiated and someone starts working on brute forcing it, well, if we rotate our encryption key every hour or something like that, well, you're going to have to break it, and by the time you've broken that key, well, we've rotated to a new one, so you can only decrypt a certain amount of data. And then the other part for this is just used for proving that you are who you are. And then this is where we also exchange encryption keys for data. This isn't data encryption going on here. This is just like management channel kind of encryption that goes on in the authentication phase. So phase 2 is actually going through the networking pieces. So what subnets are we exchanging back and forth? And how do we handle the actual data? Do we encrypt it at all? Or do we encrypt it, a bunch? What algorithms do we use? And still, how often do we rotate our keys for doing this as well? So when we look at the different algorithms, let's actually pop into this in pfSense. I'll start with the MSP one. pfSense. Good question. Yeah, admin and pfSense for the password or username password. If we come over here and start to set this up, we have, for now I'm just going to scroll down. The encryption algorithm it's defaulting to is triple DES, but we could also do some leet DES work inside of here. Cast 128, that one's, I'm not actually sure what that one is, or Blowfish or AES. Which is interesting because what algorithm is missing from here? We're missing 2 fish, yeah. That one we would actually probably expect more so. And then hashing algorithms, we have SHA-1 or MD5. So, which do we pick?
Over those two?
Yeah.
SHA-1.
You would pick SHA-1 ideally because that is more secure. Is it secure? No, not really. But it's better. The difference is though MD5 is very, very fast, but we get very, very susceptible to collisions in that multiple actual key values can result in similar hashes. So there's that problem going on. Whereas SHA-1, we now know as of, well, it's not that long ago, right, that there are collisions that we are able to now start to find inside of SHA-1. Is that a super common thing right now? No, but we know it can be done. So if you have a VPN that's using SHA-1, should you just quit? Probably fine for right now. So I actually would go with, for how we would go through to actually set this up, there's 2 phases and we have to pick hashing for both phases. For phase 1, for proving who you are, and for phase 2 for just exchanging data. I would use personally SHA-1 for the authentication phase, and actually use MD5 for the data exchange phase. Any guesses why?
More throughput if you're using MD5.
Yeah. So when we look at phase 1, how often does phase 1 authentication happen?
Just begin.
Yeah, when we first try to light up the VPN tunnel and actually start the exchange, it's going to be that's going to happen. And whatever lifetime we give it. So there's a key rotation we're going to give it. So the keys are going to get rotated every so often. So we would use the more expensive stuff there. Whereas phase 2 authentication, we're actually encrypting and shipping packets back and forth on a constant basis. And we're rotating our keys very, very quickly. Well, it can be very, very quickly. So there, since the encryption basically is rotating so often, the likelihood of getting hash collisions being a problem for us isn't going to be a big deal because the keys are rotated all the time. There's also a little test that I did a while ago. Does anyone know what a MIPS processor is? Or where you'd see a MIPS processor? So, well, either way, well, I'll show you it here in a second. So a 680 hertz MIPS processor. These are the tests that I did. So with MD5 hashing going on, I actually get a very decent throughput on the device. The actual device I was using was this, just running DDWRT. So this device itself, does it take By default, does this do VPN? No. Oh, it's a home router. What does DDWRT do?
Firmware.
Yeah. It's a DD dash. Yeah, there we go. There's a couple other flavors, so DDWRT isn't like the only one, but for a good number of home routers, you can actually go and reflash the crappy firmware that whoever puts out and put firmware in there that can actually do cool stuff. So that's what's neat about DDWRT. So I would tell you to take a look at it. Being the disclaimer that if like you brick your router, it's not my fault. Because you're totally reflashing the firmware and you can totally brick the router if you do stuff. Like the common one though, where this came up from, is the Linksys series of routers. So a good number of them are actually supported, although there's apparently a couple not possibles for some reason. Or no's. But anyway, so I found anywhere. I have not personally come across many routers that aren't actually supported with this, depending on what you have. And then, of course, Safari Apple Ping, nice. He puts a space in Linksys. So anyway, there's actually an ideal setup that we can kind of have inside of here. So yeah, I would set up the heavy CPU stuff right away, and then go something lighter for phase 2 because those keys are expiring more often. We'll see where we actually configure the keys expiring more often inside of the GUI. Ideally, if you have done this on a like Juniper or Cisco router or something like that, you'll find it's very easy to set it up in pfSense because it's just a GUI with some drop-down menus. And then it spins up a VPN for you. So what we have is 2 offices. We're going to set up a VPN between the 2 LANs so they can route between them only using internal IP addresses. That's the thing, is we have a WAN interface bridging the 2, but we're only going to use internal IPs to communicate from one computer to the other. So this is, in doing VPNs, this is one that I notice folks sometimes have trouble with. So ignoring that the WAN IPs are actually private IPs, pretend that they're not. What is wrong with this network right now? If
They ignore the WAN IP.
Well, ignore where I have WAN and then it's actually private IP address. Pretend that those are public IP addresses here.
Well, the LAN addresses look like a problem to me.
Why are they a problem?
Because they're the exact same.
Yeah, they're the exact, well, and this router can have a .1 and this router can have a .1, right? Because they're independent routers doing that. But what's the problem with sameness here?
Well, they issue DHCP independently. So
They-
there could be multiple IP addresses in one network.
We could have collisions of IP addresses. It's and they'd be the same broadcast domain. Yeah. Think about when we establish a VPN tunnel between these 2 devices, we are telling this device and this device to route between each other. So when this computer sends a packet to 192.168.1.100, hands it to this router, what's this router going to do? It's going to hand it back. Is it going to hand it over here? No. So that's where, with what we're doing, we are only operating at layer 3. If we did L2TP, anyone heard of an L2TP VPN? It's a layer 2 tunneling protocol. Then you could do that. But oftentimes L2TP is not used for that purpose because why? What's that? Yeah, because you have to ship what sort of packets? All this, yeah, like stuff Sid was saying, like all the crap you don't want to send over a VPN, like broadcasts and stuff. So, yeah, what we actually want is something like this, to where this particular box is going to have a fully different subnet. That way, once they've connected to each other, they will update their routing tables and actually be able to route between each other, and life will go well. So, the setup process of this. Open this up. And back in my phase 1 stage here. Oh, and I don't know the IP address of the other box. So I'll actually have to go look. (24, 220, 181, 101). There we are. Okay. So from inside of our MSP admin, we have to give the gateway or the actual WAN IP address of the other router. That's all right. We can give it a description if we want. The other one that's really important for this is choosing what interface this is running on. Because if you pick the wrong one, that's going to give you grief. Then, what type of authentication do we do? If we wanted to do pre-shared keys or RSA, for now, just for the sake of time, we'll just do pre-shared keys, which means we are going to give each one a password that we would want to be super secure and hard to predict. And then the 2 different negotiation modes that you have. So this is like when you start to actually set up the tunnel. There's aggressive and main negotiation modes. The main mode is the more secure way of doing it. Aggressive mode basically skips and makes some cryptographic assumptions between the 2 devices. So what can theoretically happen is someone could actually inject packets in there and be like, oh yeah, I really wanted DES. Yep, for sure. And just kind of skips verifying it. So not that that's super, super likely because we're doing like IP verification. So someone would have to essentially route hijack you and take over your IPsec VPN at the same time. So it'd be a bit of a hardy task to pull off. So the identifiers that we use, so we could set up actual certificates for this as well, or give them names or something like that. But IP addresses are going to work really good for that. And then the key, what's the key going to be? We can do password 1. Well, it should be password 1, bang, yeah, there we go. So that's where, so the policy generation stuff, those we don't tend to worry about unless we have something really, really crazy going on, like odd devices on the other end to mess with. Encryption algorithm, I would probably do AES and choose the hardy one. Do the SHA-1 hashing because we don't have a better choice for actually doing identifier or identification. And then what's DH stand for? Diffie-Hellman. So what this is specifying is when Diffie-Hellman does that key exchange, that's where, when we're talking about the paint colors mixing, right? So we have 2 devices, 2 routers sitting out there that, have we given this anything to actually generate an encryption key to actually do private data right now? We gave it a password, but that's just a verification phrase. So when we actually go to spin up the key to actually encrypt data back and forth, that's where Diffie-Hellman comes into play. So this router is going to generate a random number, and the other router is going to generate a random number, and then they're also going to publicly in the clear generate or create a open number that everyone can hear. Then they each have their own private numbers. They mix their math together and swap them, and mix their math back in there again, that's private, and then they now have identical keys. So the last question we're asked is, what is the lifetime of this? So how often do we regenerate all of these things? And it's, what's the default, 28,000? 28,800 seconds? So that's seconds, it's 480 minutes. Every 8 hours, we're going to regenerate this key. That's probably safe. Even though we know that SHA-1 hashing has been susceptible to basically 1 collision now. every 8 hours of regenerating it, we're probably going to be okay. The other couple things is NAT traversal. So this is a big deal because when we start shipping these packets around and we're looking for these IPsec packets coming in, we need to verify that we can actually ship them across NAT. This isn't so much a big deal because we're going to be actually encrypting everything, so the IP packets will actually be encrypted in their payload. But when we enable NAT traversal, that's the idea is without it, the routing breaks. Is the moral of the story. Then the other thing that we have is some devices, when we have dead peer detection going on, what we're doing is basically specifying like what's our bar, our margin for saying like this VPN is down, like totally gone. So we hit save on those. Any questions thus far? Nothing? Here. We'll do IPsec again. And come back in here and create it for the other side on the Chicago one. And the address will be 102. Boop. And we'll do the same stuff. And I think I switched that to be main mode. Our encryption algorithm was AES-256. And I used Diffie-Hellman group 5. So that's our first step. So all that these would do, assuming they actually kicked off and started running, is prove that they are who they are. No other things would actually take place at this point. So to go a step further, we need to actually set up the phase 2 portion of this. So phase 2 is where we're actually going through and figuring out, here are our routes that you need to add to your routing table, and here's how you're actually encrypting all the data. So if you keep hitting the little pluses, you'll get to the stage where you're adding a phase 2. I am still on the ORD, the Chicago one, by the way. A fun thing in here is choosing if you want to tunnel or transport. So that's going to make or break your routing inside of here. So we give it the subnet of the other side. And then actually choose, are we going to encrypt traffic or just authenticate it? Which in our case, we probably want to encrypt it. And I'd maybe do AES-128 for the actual encryption of the data with MD5 to verify everything coming back and forth. And this is where, what's the lifetime? It's 3,600 seconds. Is that an hour? Yep. So, thank you, Windows. That's exactly what I wanted. So 3,600 seconds. We're going to regenerate our key that we're using for exchange or for exchanging data here every hour. So the likelihood of this being broken is relatively small. Why would we want to automatically ping a host? Yeah. What will VPN devices typically do? Well, some do, some don't. If there's no traffic going over a tunnel. Yeah, they shut it down because they're like, hey, there's no reason for me to be doing this extra work right now. I might as well just shut down this tunnel. So that's a pro and a con, right? If you don't want your router doing all those extra CPU cycles, you can have the VPN shut down when it's not in use, and that's, I guess that is what it is. What's the downside to doing that?
I'm sorry, to letting it close or to
Yeah, what's the downside to letting it close?
set it back up again?
Yeah. As soon as your router gets a packet and then it's like, oh shoot, I have to send that over the VPN tunnel, it now has to reestablish the connection, which that actually takes a second to do. I mean, like, not like 5 minutes, but like a few seconds. So users would notice the first time that they go to do something in the morning, there's really high latency at first for the first person of the day, and then everything is fine. So I would just personally leave it up. I guess the tinfoil hat mechanism would be like, why are we putting out extra encrypted data that someone could try to break? And then you'd be like, well, we're rotating the key every hour anyway, so we don't really care. They can try to break it, and they'll get an hour's worth of ping packets in the middle of the night. So that's what that's doing. We'll save that. And then I need to pop over to the Minneapolis one and do the same thing. Ooh, here's a fun one. While we're talking about VPNs, should you ever use this? No. Windows is cool with it. Well, actually, newer versions of Windows probably aren't as cool with it. For PPT, it's very, very easy to set up, though. Yeah. Here's a good DEF CON talk to watch with Moxie Marlin Spike going through that. I wonder if he has his actual... Nah. Well, anyway. PPTP is a very bad protocol. Like, there's stages inside of there where Microsoft, of course, dreamt this up. And there's areas in there where mathematically for their encryption algorithm that they're dreaming up to work, they like, well, the user supplied a key and the key is only this big and we need to make the key bigger in order for the math to work. So guess what they tag on there? Good encryption would actually tag something random in there and make it go. Microsoft literally has, well, not literally, but basically literally, this is the string to make the key bigger. And like, it's not that exact thing, but it's something like that. Or this is the padding constant to make the key the correct size, or something like that. Is literally the string of text that they use to make your encryption key bigger. So when you go to try to mathematically reduce it down, you know that whole chunk of the key. So when you talk about the key space that you actually have to analyze, you took it from like something big to like bloop, down something really tiny. And then computers are good at math. So then it's really easy to fix it the rest of the way. So from the Minneapolis side, 192.168.10.0 slant 24. And honestly, we could leave these all just checked. But I'll probably come in and do that. Tell it to only use MD5, and we should be good. So basically, match the settings that were on the other side. At this point, it's still not going to work. A, because it's not turned on. So that helps. It's a good first step. There's a little enable IPsec box right above the save button. We have to do that. There's another reason why this isn't going to work just yet, though. I don't think it's going to work anyway. Any guesses why? Oh, maybe it will. Well, so that's not ideal. The allow all. So maybe it did actually work.
You have to hit apply.
Oh, did I? Maybe I got lucky in the reload. Best firewall doesn't block any packets. No user complaints. That's something to pad your resume with. We didn't get any complaints from users about the firewall. So we should be able to go over to status of IPsec. Oh, it's yellow. Let's try to restart it. Oh, there's green. We do like a green status. So to actually get to that, should be able to go status, IPsec. Like so, and that will take you to this page. If it's yellow, that means it's like in the process of negotiating, but hasn't came through. So what your problem probably like literally is you clicked enable on one and hit apply, and it started, and then you went enable and hit apply on the other one, but by the time you did that, the other one had given up. So if you just hit the restart button, then they should be fine. The other fun thing is I want this. This is where you never go again, right? Never ever come down into here and look at logs for stuff. So this will be the same thing for the Open VPN lab, right? When you come in here, I wouldn't expect that anyone's going to look at an Open VPN error and be like, oh, well, clearly I have a certificate error or something like that. But when you take the information from within here, what can you do with it? Yeah, you can learn from it. Oh, crazy talk. No, so you actually start searching the internet with it, right? Are you probably the first person that's ever set up IPsec? Or, well, that too. OpenVPN? No, probably not. So chances are real good that someone out there has also encountered a similar problem. So that's where we have the opportunity to start to play with this and figure things out. So well, I guess I didn't really finish we should prove that this really works.
If you were to configure where you said yes to using, or the other end is using NAT. So like say I were to set this up on my router at home and on my laptop here. And if I were to go to, say, well, I answered my own question.
Okay.
The rubber duck strategy.
Rubber duck strategy? What's that?
When you explain your problem to a rubber duck.
Oh, for sure. For me, that's Tom Halverson.
I'm sure he appreciates that.
There's been all sorts of days where Tom and I are over in the data center and there's something VMware related that's just exploded and he's there with me. And he has no idea how any of that infrastructure works, or like when I'm in a fiber channel switch tinkering around, he's like, these aren't even IP addresses, what are you doing? But actually explaining the problem out to him, and then he admits, like, I'll just ask you a dumb question. And that's what he does, just asks a dumb question, and it's like, oh, yep, I know, because it makes you think of something. Because you have to explain your problem to someone else. So I guess I like the rubber duck strategy, or the rubber duck. What would you call it, rubber duck theory?
That's what I always
Rubber duck, okay.
It doesn't describe them.
Yeah. Rubber duck debugging? Oh, yeah, here we go. In software engineering, rubber duck debugging. Huh. To the duck. Well, there we go.
I should really do that too. That might help with all my midnight projects.
Yeah. And that will be my new encouragement. I know I can usually tell when students are emailing me questions, but they're not really emailing me questions, they're working through their problem, because I'll get like a question every 45 seconds in my email, and I'll just see them coming and going and going and going. And I actually, when I see that happening, usually deliberately won't reply, because if I honestly wait 20 minutes, by like talking it out over email to me, you figure it out. So when that's happening, I might start to poke in and interact a little bit and point you in a direction, but I usually just kind of subtly stand by and wait, and then usually, a half hour later I get like, oh, I figured it out. It was a IP address or something. So, anywho, what's that? Yeah, I'll just send a picture of a rubber duck. In theory, that's not working. Oh, a couple problems. So the first one, inside of here, when you spin up any of the VPN interfaces, it actually creates a firewall, or when you spin up a VPN, it actually creates a firewall interface for you to go make firewall rules for. So now that I spun up an IPsec VPN, that actually is acting like a new interface. So we actually have to make firewall rules for it. So for the sake of, well, I'm just going to ping it. So I'm just going to do ICMP from anyone. And now over on the other side, this connection appears to have dropped. There we go. Oh no. What else could be my problem? Troubleshooting meisters. Shouldn't be NAT because we're bypassing NAT and the VPN's up. So NAT shouldn't be a problem anymore. I don't think I need to add the rule to both sides, but we'll give it a go. Whoops. I have a pretty good idea of what I need to check. I'm just seeing if anyone knows. No other guesses when I try to ping a box and it doesn't reply? Ping a Windows box and it doesn't reply? Yeah. Why when I said Windows box did that? The word association.
Is there a reason Windows disables that by default?
Well, you gotta be delete and hide. I'm guessing it's the Windows does its, what does it call them? Location specific firewall stuff. So there's like your home, work, and public. And I'm assuming, I opened up the wrong, well, this one's right, but I'm guessing the public profile must be the active one on here right now. So on the public profile, it's like, you're in a hotel, no one needs to ping you. Like, that's just unnecessary. Whereas on the, if you actually switch it to the private profile, I'm pretty sure it actually does allow ping. I'm not pretty sure. I'm somewhat. My level of confidence is actually going down. I think it might actually allow ping. So I could do the right thing and, whoops, I'm pretty sure I'm on public profile. Do the right thing and actually make the rule, but just for the sake of making this go quick. Oh no! Maybe it is on private. Confidence is getting really low now on Windows allowing ping on the private profile. Yeah, confidence is awfully low on that. I don't know why Windows blocks ping. Because it sure would make our lives easier, right? For stuff. But like, not even just in this class, but like in life, it would make every sysadmin's life way easier if Windows would just let you ping it. But anyway, the IPsec tunnel worked because I'm now on where I currently am is 10.100, and I was able to ping 1.100, and life is good. So for the, does anyone have IPsec questions? How about that? Nothing. All right. So for OpenVPN, you'll go through and configure pfSense to be the server, and you will set up the associated configuration from here. It's normal for this to actually use UDP for OpenVPN. Why UDP? I don't even know if it's necessarily that. Yeah, we don't have to deal with all the TCP overhead. What about losing packets, though? Yeah, like there's how many UDP packets do we really drop? Unless we're like, I mean, generally speaking, not that many. The only time where we lose UDP packets is when you're doing stupid crap like me all the time and I'm going to see how many packets I can pump through this interface before it dies, right? There's that. But otherwise, you don't usually lose that many UDP packets. The second thing is we're using UDP packets to transport stuff. What are we transporting inside of the UDP packet?
All the normal packets.
And what would a normal packet have in it?
Checksum. Or
A checksum, which would be a part of what kind of packet? What kind of header? Yeah. So generally speaking, we are using UDP pails. We're using UDP buckets to carry TCP water, right? The UDP packet is going to have a TCP packet inside of it, which seems kind of screwy. But in the end, we don't need to double check the verification of stuff. If by the time the UDP packet makes it to the other end and something happened to it, the receiving end, when we get rid of the, rip the UDP envelope open and pour out the TCP, is going to filter through all of that and be like, you need to resend me this packet. So TCP is still going to do its job. It just how happens that we're not relying necessarily on IP at the next layer to carry the packet. We're actually, well, we are to an extent, but we're relying on UDP to carry the TCP packet. So we still have TCPs like mechanisms for fixing problems inside of here.
So this is offloading the checking onto the client, not the router.
Yes.
That's kind of the purpose there.
Because otherwise, what would happen is when you, a VPN client, wanted to send a TCP packet from client to server, your client is going to send a SYN packet. The VPN is going to take it and send a SYN packet and do the whole, get the SYNAC act, do the whole three-way handshake. Then the first packet of real VPN data it sends is going to be a SYN. And then so if we use TCP, which you can still do, but if you use TCP to carry VPN data, you're effectively doubling every three-way handshake you have to do. So when you actually look at the math of the data we exchange, typically being people nowadays, it's very short, bursty amounts of data. So the overhead of TCP is gotten worse in life because we're not doing huge transmissions all the time. We're doing little blobs here and there. So it actually can make a huge difference in actual bandwidth use with stuff. The couple things to take a look at, and I don't want to go through and tell you these are don't check this box or don't check that box, because there's many paths you can take when you go to configure this. So there are times where you can uncheck that box, and that will have certain ramifications depending on what your configuration is. And if you had things set up a certain way, unchecking that might fix it. Or unchecking that box might make your problem worse, depending on what avenue you're going down. So that's where I'm not going to go through super specific stuff there. The things I will talk about, though, the tunnel network, that is the OpenVPN interface we make. That's the routing it's doing between the router and your client. So it gives you the example of 10.0.8.0.24. That's great. Use that. It's fine. Use something else if you want. That's cool too. Just don't use something that exists on the networks. If you do that, that will cause a conflict. The other stuff like that, if you turn on compression, for example, you can do that. That's cool. Just make sure you basically are matching configuration again. If you turn something on the server, you have to turn it on the client too. So if you tell the server to compress packets, or on the flip side, if you don't tell the server to compress packets and you do tell your client to compress its packets, and then you look in your server, you'll find logs that are I don't understand this packet. That's not what they say, but they say something of corrupt header or something. That's basically your server being I received a packet and I didn't get it. I don't understand what it means. Which is similarly if you send me a text file and I open it and life is good, If you send me a zip file and I open up the zip file in Notepad, am I going to understand what you sent me? Probably not, right? So there is one cool thing that I specifically, there's the newer versions of pfSense will actually kick out the entire OpenVPN configuration for you, which is why we don't use that. But there's a slightly older version that didn't do certificates either, and you had to actually use OpenSSL to generate your own certificates. I'm not going to make you all do that because that caused a great. Well, I have to say, being me, like, it's not that hard if you just follow the instructions, but I get it. It's a challenging thing to actually do. So pfSense has a certificate manager in here. So it will happily create keys and certificates for you. You do have to get them, so what you can actually do, and this seems kind of hokey, but if you open up your firewall admin interface to your client, then you can download the certificates out of there. So one thing you will have to do, you'll have to make a certificate authority. What does the CA do? Yes, a CA is the issuer of the certificates. It's the authority. It doesn't necessarily need to be like a server. A certificate authority is really a blob of cryptographic data. So, I mean, there's actual server parts to it. But what we're going to do is create an internal CA. Something like that. And then you'd fill out the form. This is a normal thing. And for a certificate authority, this is valid for 10 years. Yeah, that's probably about right. There we go. So that is our certificate authority. Now, when we go to actually generate certificates, there is a web configurator default certificate in here. Do you want to use that for anything?
Probably not.
No. What's that cert for? That's for accessing your firewall's admin interface using SSL. We don't want to use that for VPN. So we would go make a new certificate. You're not going to import it. You're going to create an internal certificate. And who's your authority going to be? Well, we just made one. And then you choose your kind of certificate that you have. So for OpenVPN, for the server side of it, it's going to want a server certificate. So it's going to go and create all this stuff. I'll call it server, hit save. The description field's required. Server. There we go. So there's a couple download buttons here. Now, I'm not saying that this is necessarily going to make or break your configuration. It's just an incorrect thing that I see sometimes. You need your server's certificate on all of your clients. Makes sense? So you have to validate it. You also need the CA's certificate. Well, there's a way you can do it without the CA, actually. But you probably need the server and the CA certificate on there. Do you need the keys for them on the client?
Should be transferred when you try to.
You should never remember, because vomit of the mouth of words. When you go to PayPal, do you have the private key for that certificate? I would assume not. Anyway, that'd be pretty cool if you did. You should let me know how you got it. Do you have the public key for it? Yeah. So the other way of phrasing that is you have PayPal's certificate, but you don't have the key, is how they've described that. So that's what's going on there. You would bring the certificate for the CA and the server, but not the keys. If you go down the route of configuration where you make a client certificate, does the client need a certificate and a key? Doing public-private stuff. Yes, it does. Because that's what your client is going to use as its private key to verify data going back and forth. So, that's my quick little Anyone have questions? The other one that's not allowed is, well, it says allow all. It's not allowed for you to go set up routing and just make it look like you made a VPN and to ping through to the machine kind of thing. You actually have to set up the VPN. Because the idea here is that you set up a VPN and it encrypts a tunnel and then you can ping internally. And you may have to turn off the Windows firewall again. What you can't do is go and tinker with the routing configuration of pfSense to just make it work where you don't have to set up the VPN and to just route the traffic directly. So if you do that, that's not setting up the VPN and that doesn't count. FYI. Oh, as far as the firewall rule here, yeah, that's fine. That's not going to do anything. Otherwise, well, and if you want to get rid of the allow all rule, you would change it to be UDP 1194, I think is what OpenVPN runs on. Or whatever port you specify in the configuration. So then on the desktop, there's the OpenVPN client should be installed, and there's actually a sample configuration already in there already. So, yeah. Cool. Find your inner rubber duck. And that's all we got. That is our official last class period. So, see you all either next semester or at graduation, I guess.